Hi, everyone. It's so good to see you again. I've been reading your comments, and it's amazing how many of you are learning, sharing, and opening up about your own journeys. That's what this space is for, learning together with kindness and curiosity. I'm Mrs. Parkinsonina, and today we're continuing our story. In our last class, we explored what really happens inside the brain, that silent collapse of dopamine that begins long before the first tremor appears. And now, we'll see how those tiny changes in the brain start to show up in the body, why movements slow down, and what's really behind bradykinesia. Let's dive in, gently and with science. So let me ask you something. Why does the body start to move as if it's in slow motion? Why does each step feel smaller, each gesture slower, as if the body is out of sync with the will to move? Bradykinesia is one of Parkinson's most recognizable and most misunderstood symptoms. It's not about weak muscles or lack of energy. The problem isn't in the legs or the arms. The answer is the role of dopamine, a neurotransmitter crucial for sending signals that control movement. Imagine you want to walk across the room. Your brain says, go, but your body answers, wait. That tiny delay, that hesitation, is the science we'll explore today. The story behind why the body begins to slow down. Movement doesn't start in your legs, it starts in your brain. Specifically, in a group of deep structures called the basal ganglia. These circuits act like the brain's gearbox. They decide when to start, stop, and adjust the intensity of movement. But they don't just control it, they modulate it. They fine-tune every motion, from blinking to walking to smiling. And the key that keeps this system running is dopamine. Dopamine provides dopaminergic modulation of movement. It balances activation and inhibition in the motor circuits. When dopamine is at healthy levels, movements are smooth and fluid. But in Parkinson's, that modulation is disrupted. The gears that once turned freely start to grind and slow down. With reduced dopamine, the inhibitory circuits become overactive, and the excitatory circuits lose strength. This imbalance means the brain's go signal is too weak, while the stop signal grows stronger. So, even when you want to move, your brain can't send the message with enough intensity. It's like pressing the gas pedal, but the car barely moves forward. That's why movements become slower. That is why rigidity occurs. That's why walking turns into small, shuffling steps, with reduced step length and gait speed. And that's why facial expressions fade, as if the emotional rhythm slows too. Bradykinesia isn't the body being lazy, it's the brain's signals arriving late, the orchestra playing out of rhythm. So, what can we learn from this? That slowing down isn't giving up, it's part of adaptation. Your body is adjusting, your brain is still learning. Understanding bradykinesia helps us see Parkinson's not as paralysis, but as a communication delay between brain and body, one that can be worked on, trained, and improved. Education is part of that training. The more you understand how your brain works, the better you can move with it, not against it. Here on the Parkinson's channel, we combine science and empathy, because knowing the why behind each symptom helps you act with confidence and calm. And this story doesn't end here. Now that you understand why the body slows down, in our next class, we'll dive into a crucial question. How do doctors actually diagnose Parkinson's disease? We'll explore the science behind the diagnosis, what doctors look for, and how early signs are detected. It's a topic that clears up a lot of confusion and helps patients and families recognize the process with clarity and calm. So don't forget to subscribe to the channel, hit the like button if today's class helped you understand a bit more, and leave a comment sharing what part of this video made the most sense to you. Your interaction helps this content reach more people who are on the same journey of learning and awareness. Stay tuned, because the more we understand, the better we can live with purpose, knowledge, and hope. Science never stops, and together, neither do we.